Topic: electric vehicles. At my side, Andreas, our top product manager for automotive technology. You have seen the three distinct systems in the background several times before. We don't want to delve into great detail today. However, today we specifically want to specialize in the topic of diagnosis. We know all systems are perfectly suitable for the various qualifications, no matter whether it is the DGUV in Germany, the IMI qualification, or even the ASE L3 in the United States of America. Each system comes with an e-learning course, and we have all the necessary measuring instruments on board. But now we should focus on the pertinent question: what diagnostic options do we have for each of the three systems? For this, I have my expert here at my side, and we are commencing with it. Andreas, with this system, which is less specialized in automotive technicians, but rather in rescue forces, we also have various error scenarios to carefully consider. I wouldn't necessarily speak of diagnosis in this case, but what options do we have with this system so that firefighters, for example, understand how to properly handle such an e-vehicle in an accident situation?
So the situations that are built in here are actually primarily the situations that can present themselves after any given accident. This means, on the one hand, firstly here, a fault in the high voltage system, that the high voltage system did not automatically disconnect after an accident. This means that the main contactors, the main relays in the vehicle are welded, and therefore, although the vehicle is switched off, there is still high voltage everywhere.
Which of course can also happen if one has not had an accident yet. If the vehicle is older, the battery is older, then of course such a thing can naturally happen.
Exactly. If the relays are naturally pre-damaged, an error like this can happen because it's not evident from the outside. Exactly. So this is really only verifiable by measurement. There is no external indication at all. Okay, what else do we have? The second error, notably, involves damage to both the vehicle and the battery, which is quite concerning. If we are taking the thermal imaging camera now, we can already see that the vehicle is gradually heating up in the specific area of the battery located at the back.
So here it is essentially about the contactless measurement of temperature, because we do not have a diagnostic device as a firefighter or anything else, so that we can then determine whether the battery is still okay or not okay. Because even if it looks intact from the outside, it could still have taken a hit, which could then lead to a short circuit in the cell.
Exactly. You often can't see it from the outside, or the batteries are built in such a way that you can't see whether the battery has now been mechanically damaged or something like that. However, one can indeed still ascertain through a thermal imaging camera whether there is any damage at all, just as it is systematically done later in practical use indeed.
If I continue here now, for example, we have a vehicle underwater. What can we learn there?
Here we have the situation where the vehicle was pulled out of the water. That means, as we can see here, LEDs are attached everywhere on the doors to represent door locks. The onboard electronics themselves are actually acting up. The car locks and unlocks. Water is everywhere in the control units, for example. And of course, the battery was also full of water and was cooled by it. And we will now find that after some time, the battery, after the water that has so far cooled the battery when the car was in the water, has drained. The battery also heats up due to the damage that has occurred in the battery.
Okay, I understand.
And then indeed we have the burning automobile. Yes, the burning vehicle is actually precisely what it means. It's burning, the vehicle is burning. We see the onboard electronics are going crazy again, just like with the vehicle underwater. And interestingly, the vehicle also heats up again after a certain period of time.
It is important to say here, we are not assuming a battery fire, as in part 2, or as it will result from it, but here it is really about having a fire in another area, and of course it can quickly spread to the HV system and the HV battery.
Wonderful. And finally, let's turn our attention to situation 5, the trapped driver scenario. The vehicle remains active. We are still in the 300-volt range everywhere. The vehicle is not unlocked, has an auto shutdown. The ready mode is still on, yes, but indeed the driver is trapped, and sadly the door just won't open. This means essentially the driver would absolutely have to be saved by immediate, urgent measures.
But what we definitely should not do, what we should avoid at all costs, is to cut in here somewhere.
Yes.
Very nice. Definitely in an area where we've forbidden high components. Firstly, thank you so much here. Those were 5 very nice scenarios. We discussed this during development with the fire department and vehicle manufacturers about which scenarios are more likely in reality. These are precisely those 5 scenarios. Thanks, Andreas. With pleasure.